Welcome back for another deep dive. Are you ready?
Always.
Today we're looking at music and AI, specifically how the latest breakthroughs are changing the way we think about sound, like how we create it, how we experience it.
How we understand it, even.
Exactly. We've got a whole stack of fresh research papers.
All from February 19th, 2025.
Hot off the press, straight from the Arxiv.
For those who don't know, it's basically a digital preprint server.
Yeah, where researchers share their findings like right away.
So we're getting a real-time snapshot of a field that is changing so rapidly.
It's mind-blowing. I mean, get ready for AI that can transcribe melodies with like perfect rhythm.
And models that learn by basically playing sonic jigsaw puzzles with themselves.
And even algorithms that can pick up on like really subtle hints of cognitive decline just from listening to someone's voice.
All of that and much more. But maybe let's kick things off with this paper that really grabbed my attention. It's called Note-Level Singing Melody Transcription for Time-Aligned Musical Score Generation.
Okay, cool. But don't most transcription tools already do that? What makes this one different?
Well, think about it this way. Imagine you're trying to write down the notes from like a super complex guitar solo.
Okay.
You could probably get the notes right, but to get the exact timing, the duration of each note, that's the tricky part.
Right.
And this AI not only nails the notes, but it figures out the exact rhythm too, so like the note values, and then it can actually generate a musical score that syncs up perfectly with the audio.
Oh, I see. It's like going from a rough sketch to like a super high-definition picture of the music.
Precisely.
So what kind of impact could this have?
Well, the implications are huge, especially when you think about accessibility for musicians who maybe have disabilities that make it hard to read traditional sheet music.
Oh, yeah.
This tech could open up a whole new world for them, and beyond that, it could totally change automatic song analysis.
Interesting.
And even help composers create new arrangements based on a vocal performance.
That's incredible. But to create an AI that can understand music like at this level, that must have been a massive challenge, right?
Oh, absolutely.
What were some of the hurdles the researchers ran into?
One of the biggest ones was actually the lack of readily available data on note values.
Oh.
So to get around that, they used a technique called pseudo-labeling.
Pseudo-labeling. Okay.
It's kind of like teaching a kid to draw by having them trace over dotted outlines first before they go freehand.
Right.
So basically, they used algorithms to estimate those note values from existing data sets that only had note information, and that gave the AI a sort of rough draft to learn from.
That's so clever. Like they bootstrapped their way to a more complete understanding of the music.
Exactly.
And I'm sensing a theme here. Clever solutions to complex problems. All with the goal of pushing the boundaries of what AI can do with music.
Absolutely.
And speaking of pushing boundaries, this next paper is all about an AI called Mina, masking-based contrastive learning of musical representations. It even sounds kind of like a superhero name. So what's Mina's superpower?
Well, Mina's superpower is its unique way of learning. Imagine taking a piece of music and covering up random parts of it, like making a sonic jigsaw puzzle.
Okay, yeah.
That's basically what Mina does. It masks sections of the sound and then tries to predict what's missing.
Wow.
And by doing that, it's forced to really understand the relationships between different musical elements.
That's cool.
Right.
But the thing that really stood out to me was the sheer scale of this model. It can handle a batch size of 4096 during training, which seems huge compared to other models that max out at like 48 or 120. Why is that such a big deal?
So batch size refers to the amount of data the AI can process at once during training.
Right.
So a larger batch size means Mina can learn much faster, and it could potentially lead to even better results.
I see.
It's like having a supercomputer dedicated to music analysis.
Wow. So Mina is like this musical savant devouring music and figuring it out at an incredible speed.
That's a great way to put it.
And you mentioned earlier that this AI is particularly good at key detection. Why is that?
Well, unlike some other methods that might distort the audio while they're learning, Mina's masking approach keeps all of that pitch information intact, making it super sensitive to the nuances of key and harmony.
So if you're really into understanding the tonal structure of music, Mina could be an invaluable tool.
Definitely.
That's fascinating. Now, for something completely different, let's talk about an AI that can sing. This paper is called Tech Singer, Technique Controllable Multilingual Singing Voice Synthesis via Flow Matching. And it introduces an AI that can not only sing in 5 different languages, but it's also mastered 7 different vocal techniques.
This is where things get fun.
7.
Imagine an AI that can switch between normal singing, intense belting, mixed voice, falsetto, bubble tones, breathy vocals, and even whispering. Tech Singer can do it all.
Hold on, 7 vocal techniques. That's incredible.
It is.
I'm picturing this AI hitting those Mariah Carey high notes.
Oh, yeah.
And then switching to a soft, breathy whisper like Billie Eilish. The range is mind-boggling.
The possibilities are pretty much endless.
But what really intrigues me is this whole idea of controllability. You can actually tell the AI to sing with more breathiness or to switch to falsetto whenever you want.
Exactly. That's what sets TextSinger apart. It's not just about mimicking a human voice. It's about giving the user the power to shape the vocal performance.
Wow.
You could create personalized music where you adjust the AI's style to match your mood, or you could even use it for vocal training,
Oh, interesting.
getting instant feedback on your technique and experimenting with different styles.
It's like having a virtual vocal coach in your pocket
That's a great analogy.
that can adapt to any genre or mood you can imagine. I'm already picturing the possibilities.
Me too.
And you mentioned there are audio samples online.
Yes.
We'll definitely have to include those in the show notes. This is one AI I have to hear to believe. Now let's shift gears to something even grander, deep resonance. Enhancing multimodal music understanding via music-centric, multi-way instruction tuning.
Now that sounds ambitious.
It does. So what's the big idea here?
Deep resonance basically takes music understanding to a whole new level by combining sound with text images and even video. It's like they're training the AI with a multimedia encyclopedia of music.
So it's not just listening to the music, it's also seeing the album art, reading the lyrics, maybe even watching the music video. That's a lot of information to process.
It is.
How does it even begin to make sense of all of that?
Well, the key is this technique they call multi-way instruction tuning. It's like teaching the AI to respond to these complex instructions that involve different types of media. Imagine giving the AI a command like, show me a video of a song that evokes a feeling of nostalgia with lyrics about lost love and a visual style like old film noir. Deep Resonance can take that whole complex instruction and find music that matches all those criteria.
Whoa, that's seriously impressive. But what's the point of teaching an AI to understand music in such a complex way? What kind of real-world applications could this lead to?
Well, imagine searching for music based on emotions, visual aesthetics, or even thematic concepts.
Okay, yeah.
So you could search for music that feels like a warm summer evening or sounds like a film score for a cyberpunk thriller.
That would be amazing.
This level of music understanding could totally transform how we discover and experience music.
It's like the AI becomes a musical sommelier, curating the perfect sonic experience for your every mood.
I like that. A musical sommelier.
Now get ready to be blown away because this next paper is all about high-fidelity sound, high-fidelity music vocoder using neural audio codecs. Might sound technical, but trust me, this is some seriously cutting-edge stuff.
It really is. This paper introduces Discoder, an AI that uses neural audio codecs, which are basically algorithms for compressing and decompressing audio to generate crazy realistic music from spectrograms.
Hold on, back up a sec. Spectrograms. You're talking about those visual representations of sound frequencies, right?
Yeah.
So this AI is taking like a visual image of sound and turning it back into something you can listen to.
Exactly. And not just any sound. We're talking high-fidelity music that captures all the little details of the original recording.
Wow.
In fact, Discoder actually outperforms existing models on objective metrics and even in listening tests using a method called Mushar, which basically compares different audio codecs based on human perception.
That's incredible. It's like taking a blurry picture of a beautiful landscape and then using AI to reconstruct it in super high definition. All of a sudden, you can see details you never even knew were there.
That's a great analogy.
But what's the big deal about having an AI that can generate this super high fidelity music from spectrograms? What kind of impact could this have on the music industry?
The researchers believe Discoder has the potential to be a universal vocoder, meaning it could be used for both music and speech synthesis.
Oh, wow.
Imagine creating music with lifelike instrumental textures, generating super realistic voiceovers, or even synthesizing whole songs from scratch with insane fidelity.
That is officially mind-blowing.
Right.
This really feels like we're stepping into the future of audio creation.
It does.
But all this amazing AI requires serious computing power. Right, that's where our next paper comes in. Keep what you need, extracting efficient subnetworks from large audio representation models.
Now that sounds practical.
It does.
It really does. This paper addresses the issue of AI model size. We've been talking about these crazy powerful AIs, but they need massive amounts of computing power, making them kind of impractical for everyday use. This research suggests a way to extract smaller, more specialized subnetworks from those giant models.
So it's like taking a giant Swiss Army knife and only taking out the tools you need for a specific task?
Exactly.
What's the benefit of that?
Efficiency. These smaller subnetworks can run on everyday devices, even in real time, opening up a whole new world of application outside the research lab. Imagine AI-powered music tools on your phone that can transcribe melodies, analyze harmonies, or even suggest chord progressions.
And all without draining your battery in 5 minutes.
Exactly.
That's a total game changer. It makes AI-powered music tools accessible to everyone, not just people with access to supercomputers. And this method works across different AI architectures, so it's not limited to just one type of model. It's like finding a universal adapter that lets you plug any AI into any device.
It is.
Speaking of versatility, this next paper tackles a problem that's pretty relevant to music lovers' AI models that are biased towards 44 times skip that beat. Augmenting meter tracking models for underrepresented time signatures sounds like they're teaching AI to dance to different rhythms.
It's a really clever approach. Imagine an AI that's been trained mostly on pop music, which is usually in 44 time. When it comes across a song in a different time signature, like a waltz in 34 or a samba in 24, it might have trouble understanding the rhythm.
Yeah, I could see that.
So this paper suggests a technique called skip that beat, which involves removing beats from 44 music during training to simulate those other time signatures.
So they're basically exposing the AI to a more diverse range of rhythms, like giving it dance lessons in different styles.
Exactly.
What was the outcome? Did it actually help the AI understand those less common time signatures?
The results were great. The AI got much better at recognizing and understanding 24 and 34 time.
That's so cool.
It shows that even AI can be biased, but by exposing it to more diverse data, we can overcome those limitations.
That's a really important insight. It reminds us that AI is basically a reflection of the data it's trained on. And if we want AI that can truly appreciate all the different kinds of music out there, we need to make sure it's exposed to a wide range of styles and cultures.
I completely agree.
This has been quite a journey already, from AI transcribers and sonic puzzle solvers to vocal chameleons and rhythm instructors.
It has.
And we're only halfway through our stack of research papers.
I know.
Get ready to explore even more fascinating territory as we dive deeper into the world of music and AI in our next segment.
Can't wait. It's amazing to think that AI is changing not just how we make music, but how we experience it too.
Oh, totally. Like that paper about extracting those smaller subnetworks from the giant AI models.
Right. We could have incredibly sophisticated AI right on our devices, giving us super personalized musical experiences without killing our batteries instantly.
Like imagine an AI music tutor right on your phone, giving you real-time feedback as you practice.
It could analyze your playing, point out what to work on, and even suggest exercises for specific techniques.
It'd be like having a personal coach in your pocket.
Always there to guide your musical journey. And think about AI DJs that go way beyond just your listening history.
Yeah, they could actually sense your mood, maybe tap into your biometrics even, and create a playlist that perfectly matches how you're feeling right then.
That takes personalization at a whole new level. It's like a soundtrack for your life, constantly adapting.
And what about how AI could revolutionize making music? We already talked about SongGen, which can make whole songs from text prompts. But where do you see that going?
I think AI will become a real partner for musicians, not just a tool.
So like you could brainstorm lyrics with an AI or have it compose different accompaniments for your melodies. Maybe you could even suggest harmonies you'd never think of.
Exactly. It's a total shift from AI as a passive thing to AI as an active participant in the creative process.
Almost like having another musician jamming with you, bouncing ideas back and forth, inspiring each other.
And it's not just for pros either.
Right.
Anyone could use AI to get their creativity flowing, no matter their skill level. That reminds me of the Mina paper, the one where the AI learns by masking sounds. That masking technique could be used to make interactive musical experiences.
Oh, that's interesting.
Where the listener actually plays a part.
Like a sonic treasure hunt. You're exploring this soundscape and the AI reveals hidden melodies as you go.
Yeah. Or you could have an instrument powered by AI that responds to your touch, your voice, even your movements, creating this totally immersive sonic world.
And don't forget deep resonance, the one that gets music by combining sound with text, images, and video. Imagine what that could do for finding new music.
We could go way beyond searching by artist or genre and find music based on emotions, visuals, themes. You could search for something like music that feels like walking through a misty forest at dawn.
That's a great example.
And the AI could put together a playlist that captures that feeling perfectly.
It's like the AI can read your mind and turn your emotions into music.
It really is. And speaking of reading minds that research on decoding those lexical tones straight from thing recordings, that opens up so many doors, especially for people with speech impairments.
It's incredible to think that you could communicate your thoughts and feelings through music without even needing to speak.
Such a powerful example of how AI can bridge the gap between our inner world and the world around us.
Letting people express themselves in ways they never thought possible. But as amazing as all this is, we do have to think about the ethical side of these powerful technologies.
Right.
What about the impact of AI music on human musicians? Could AI make human creativity less important?
It's a valid concern, but I think it's more likely that AI will just add to human creativity, not replace it. Just like photography didn't make painting obsolete.
Oh, that's a good point.
AI music tools will probably inspire whole new forms of music and collaboration.
It's all about finding that balance. making sure that AI helps boost creativity, not replace it.
Exactly. Another thing to consider is bias in AI models. We talked about that Skip That Beat paper that caught AI to understand different time signatures. It showed how our own biases can end up in the algorithms we create.
So true.
It's a reminder that the data we use to train these models has to reflect how diverse music and culture really are.
Right, if we want AI that truly gets the full range of musical expression, we need to make sure it's exposed to all kinds of genres, rhythms, and cultural influences.
It's like teaching the AI a universal language of music.
One that includes traditions and innovations from everywhere. And this brings us back to the importance of benchmarks like Voxeval. They're designed to really test how well AI understands spoken language.
Yeah.
These benchmarks will be key to making sure AI music tools can truly get the nuances of human expression.
It's not just about AI making music, but about AI understanding the meaning and emotions behind it.
We need AI that can connect with us on a deeper level, not just copy patterns or styles.
Absolutely. It's about connecting the analytical power of AI with the depth of human experience.
And as AI gets even more advanced, these ethical questions will only become more important.
Definitely.
It's a conversation we need to be having now as we're shaping the future of music and AI. We have to make sure these technologies are used ethically and responsibly.
Couldn't agree more. We have to be mindful of the impact on human creativity, the dangers of bias, and the importance of transparency and accountability in AI development.
It's about creating a future where music and AI can both thrive, enriching our lives and inspiring new forms of art.
Well said. And that leads us to our next paper, Improving Rare Word Recognition of Whisper in Zero-Shot Settings. This one stood out because it tackles a really basic challenge in speech recognition, teaching AI to understand words it's never heard before.
Whisper is that open source speech recognition model that's been getting a lot of attention lately,
That's the one.
but it still has some kinks to work out. And one of its weaknesses is recognizing unusual words.
Right. Think about all the specialized terms, dialects, new words that pop up all the time.
It's like trying to teach a kid to read a book full of words they've never seen before.
It's a huge challenge, but this paper offers a solution fine-tuning Whisper with a little extra data focused specifically on those rare words.
So it's like giving Whisper a crash course in all those weird words, expanding its vocabulary.
And it worked. Whisper got much better at recognizing rare words. And here's the kicker. The improvement actually carried over to languages it wasn't even trained on.
Wow. It's like it learned the underlying rules of language, the stuff that goes beyond individual words.
Exactly, enabling it to adapt to new linguistic situations.
This has huge implications for music. Think about AI that can transcribe lyrics in any language, even ones with tricky dialects.
It would completely change music education. People could learn from a much wider range of musical traditions.
And it could open up all kinds of possibilities for collaboration, breaking down language barriers and connecting people through music.
It's like getting a glimpse of a future where AI helps us unlock the full power of human expression and connect us through that universal language of music.
I love that. Wow, we've covered so much ground in this deep dive. It's really amazing to see how AI is changing music in so many ways.
It really is a fascinating time to be looking at this intersection of tech and creativity.
I'm still thinking about some of these papers like that one on Tech Singer, the AI that can sing in 7 different vocal techniques.
It's pretty remarkable. Imagine the possibilities for making virtual choirs and ensembles where every voice is AI controlled. You could have harmonies and textures that would be impossible for human singers.
I'm also really interested in that research on AI estimating underwater sound speed. It's like we're getting a glimpse into this whole world we barely know.
Makes you realize how much is still out there to discover in our oceans. AI could be this amazing tool for mapping the ocean floor, studying marine ecosystems, even finding new species.
Like having a virtual explorer going down into the depths and revealing all these secrets.
Exactly. And speaking of unlocking secrets, that paper on Step Audio, that massive speech AI with 130 billion parameters, that really got me thinking about the future of how humans and computers interact.
It's like we're right on the edge of this new era where AI can understand and even generate human language so fluently with all the nuances. Imagine having conversations with AI that feel as natural as talking to a friend.
It could change everything from customer service to education to entertainment. We could have AI companions helping us learn new things, create art, tell stories, even provide emotional support.
It's both exciting and a little bit scary to think about all the possibilities.
I agree. It's important to approach these advancements with a sense of wonder and caution. We need to make sure AI is developed and used ethically and responsible.
Which brings us back to that question we asked before. What area of music or sound do you think AI will revolutionize the most in the coming years?
It's tough to pick just one. There are so many possibilities. But I think music education has huge potential. Imagine AI tutors that can personalize lessons for every student, matching their learning style and pace.
That could make music education so much more accessible and engaging for everyone, no matter their background or skill level.
And think about AI bridging cultural divides through music. AI could help us translate lyrics and even musical concepts across languages, opening up so many possibilities for collaboration and understanding.
That's a beautiful vision, using AI to connect people through music.
It's a good reminder that AI isn't just about the technology itself. It's about using technology to make human connections stronger and boost creativity.
This has been an incredible deep dive, exploring the frontiers of music and AI. I feel like we've just scratched the surface of what's possible.
And that's what's so exciting is so much more to uncover and explore.
If you're as fascinated by this as we are, make sure to check out the show notes for links to all the papers we talked about. You can really dig into the research, see the code and models, even try out some of these AI tools yourself.
And if you have any thoughts or questions, leave us a comment. We love hearing from our listeners and having these discussions about the future of music and AI.
Until next time, keep exploring, keep listening, and keep those creative sparks alive.
The future of music is full of possibilities, and with AI as our guide, this symphony is just getting started.